Hello, 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 hello. Hello. And which is adding issues over here. Thanks. Thanks for let's get started. And yeah, so let's discuss the Codeforces division. Codeforces on 920 division 3. The problem is square. We are given a square of positive strictly greater than 0. Area is located on coordinate plane with sides parallel to coordinate axis. You are given the coordinates of its corner in some random order. Your task is to find the area of square. Each several test cases. Find the line containing one integer t, the number of test cases, and the following is a description of the test cases. Each test contains 4 integers. Each line containing just xi and yi. The coordinates of corner of the square is a square with side parallel to coordinate axis with positive strictly greater than 0 area with corners in the given points. So in this point, we are given the 4 points of a square and we are asked to find the area of the rectangle, area of the square. Like since it's square, we know that the length would be equal to breadth and the area of square is a square. So what we can do is we can try to find the coordinates, the minimum x coordinate and the maximum x coordinate, and we can take the square of that area. And that should give us a solution. So looking at code, what we can do is, or other way around, for finding the length, we can take minimum x coordinate, difference of minimum and maximum x coordinates, and for finding the area of rectangle, for finding the other side, we can take minimum and maximum, difference of minimum and maximum y coordinate. And go to the first, what I did was I created two vectors, xc and yc, x coordinate, y coordinate. And for all the point, I separately put x coordinate and y coordinate in them. I sorted all the points and then I took the difference of minimum, maximum and minimum, maximum and printed it out over here. And it looks like only 360p is there. I'll sort. Yeah, like I tried turning off and on, like so, like now the audio quality, video quality would be better, hopefully. And probably moving on to problem B. Problem B says arranging game. In order to test the hypothesis about cats, like scientists, let's just ignore this story. Scientists have n boxes in which cats may or may not sit. Let the current set of boxes be denoted by sequence B1, B2 up till Bn. B1 is 1 if there is a box, there is a cat in box I, or B0 otherwise. Fortunately, the unlimited production of cat has already been established. So in one day, the scientist can perform one of the following operations. Take a new cat, place it in a box for some I such that bi equal to 0 and assign bi equal to 1. Remove a cat from a box and send it into retirement. That is for some I such that bi equal to 0, 1 and bi equal to 0. Assign bi equal to 0. Move a cat from one box to another for some ij such that bi is 1, bj equal to 0. Assign bi equal to 0 and bj equal to 1. Like, it has been found that some boxes were immediately filled with cats. Those scientists know the initial position of cats in the boxes S1 up till Sn and the desired position F1 up till Fn. Large amount of paperwork, the scientists do not have time to solve this problem. For the sake of science and indicate the minimum number of days required to test the hypothesis. So like input, we are given a string S and we are also given a string F, final string required. And for each test case, we have to output a single integer on separate line. Minimum number of operations required to obtain desired position from the initial position. It can be shown that a solution always exists. So what we have been asked over here is we are given an initial string. We have to find a final string. And we can perform multiple kinds of operations over here. We can choose an index I and we can such that si equal to 1, we can assign si equal to 0. Or we can choose an index I such that si equal to 0 and assign si equal to 1. Other way around, we can choose two integers I and j such that I equal to 1 and sj equal to 0. And then we can assign si equal to 0 and sj equal to 1. So if we look at it, like what we can see is like operation of the third type. Operation of third type is equivalent to doing operation 1 one time and operation 2 one time. So basically, operate type 3 once is equivalent to type 1 once and type 2 once. So what we can do is we can count how many times we need type 1 operation. Which we can find by taking the number of points where si equal to 0 and ti equal to 1. We can also count the number of type 2 operations required. We find the places where si equal to 1 and ti equal to 0. And let's say we need x number of type 1 operations, y number of type 2 operations. Take the minimum of them. Let's call it z. Like z is minimum of x comma y. Then we can first do z operations of type 3. We should be doing z operations of type 1, operations of type 2. And then one of them would be like the number of one of them would be 0, and we would either x minus z or y minus z. We can later do type 1 operations and minus z type 2 operations separately. So overall our answer would be in that case minimum of x comma z plus x minimum of x comma y final answer would be minimum z plus x plus y minus z, like plus x minus z plus y minus z equivalent to x plus y minus z, where z is minimum of x comma y. One can verify the following identity. Given two number x and y, sum of x plus y would be maximum of x comma y plus minimum of x comma y. So now using this identity, we can simplify that this final answer is equivalent to maximum of x comma y. And that is our final answer over here. Now looking at the code for this one, I check some of the samples. For example, when x s, like both the strings are equal, we need 0 operations. Here if we look at it, like we have to only change 1 0 to 1, so like only one operation is required over here. Here we have two strings, like we have to change 1 0, one at one index we have to change 1 to 0, at one index we have to change 1 to 0, and at other index we have to change 0 to 1. Jump. So jumping onto the code for this one. So like I take first s and t as input. If both the indexes are equal, we don't have to do anything over there. Otherwise, I count the number of indexes where si is 1 and number of indexes where si is 0. Those are my corresponding x and y. And then we have to print the maximum of both of them. Any questions on this one before I move on to the next problem? Like, okay, moving on to the next problem. Okay, I move to F problem later, and there we can discuss what are the constants. So moving to problem C. Problem C says Stefan is a very busy person. Today he needs to send n messages as movement m1, m2 up till mn. And we are given that these m are in increasing order. Unfortunately, by the moment 0, his phone only has f units of charge left. At the moment 0, the phone is turned on. The phone loses a units of charge for each unit of time it is on. Also, at any moment, Stefan can turn off the phone and turn it on later. This action consumes b units of energy each time. Consider turning on and off to be instantaneous. So you can turn it on at moment x and send a message at the same moment, and vice versa. Send a message at moment x and turn off the phone at the same moment. If at any point the charge level drops to 0, becomes less than equal to 0, it is impossible to send a message at that moment. Since all messages are very important to Stefan, he wants to know if he can send all messages without possibility of charging the phone. So here, like input and everything is given. Let's look at one of the samples here. Like if we look at the first sample, it says, okay, let's look at the seventh sample. Like the 4 moments when we have to send messages is 6, 4, 10, 13, 17, 20 and 26. Also, what we can see is that if we turn on and off the phone, like at each moment 1 unit of energy goes, but if we turn it off and on, like 3 units of energy will be going. Now let's, like for each scenario, like, and we are also given that we have to turn on the phone at the moment 0. So like what we can do is between each messages, we can decide whether we should turn on a phone or not based on which scenario is better. What, like we have two choices at every point of time. We have two choices at every point of time. Either we turn off the phone after sending it, or we can keep running the phone over here. And if we look at the constraints over here, like for example, if the phone is on at time 0 and we have to send the next message as time 4, if we don't do anything, then our energy will decrease by 4, like phone charge will decrease by 4. But if we turn off the phone at the moment, instantly at the moment 0, and then turn it on at instantly at the moment 4, our energy, like charge, will decrease by 3. So in this case, it's better to turn on and off the phone. Similarly, if we see 4 and 6, like if we don't do anything, like within 2 seconds the charge will drop by 2, but if we turn it on and off, like our charge will drop by 3, and we should take the minimum of this, so like drop by 2 is better. Okay, now if we compare time between 6 and 10, if we don't do anything, the charge will drop by 4, and if we turn it on and off, our charge will drop by 3, and we should take the minimum of 0, minimum of both of them. Like a question, why did I prepend with 0? Like the idea is, like since we are turning it, like we have been told that we have to turn it on the phone at moment 0, even if we try to turn it off at moment 0, some amount of energy will go there. So it's similar to assuming that at time 0, we have sent a message, and now our phone has a power f, and what should be required. Or even if we don't append it by 0, like what we need is, like when was the phone turned on last time, or when was the moment you turned off the phone. So like even in 4, 6, 10, 13, 17, 20 and 26. Like at moment 4, you know that the phone must be on when the previous time was 0. And either you could have turned off the phone at 0 and turned it on again at 4, or you could have turned on the phone at 0 and you kept it as it is. Like, I will repeat again. Looks like there are some more issues. Sorry all for all the issues. Like 4, 4, 6, 10, 13, 17, 20, and 26. So like you know that you first turned on the phone at moment 0, and either you could have turned off again at 0 and then turn on at 4. Like this is one way. The other way is turn on at 0 and send message directly at 4. If you do this, your energy will charge will reduce by 4. And if you do this scenario, like there would be no charge due to like the time it's running on, but because of turning on and off, your charge will reduce by -3. So like the main idea is like we can find out the moments when the phone must be on. Those are 0, m1, m2, m3, m4 up till mn. And between each moment you can either keep the phone on. In that case the charge would be a into the time difference, or you can turn off instantly and then you can turn it on. In that case the charge would reduce by b. And what we can do is we can take minimum of both of them because we already know when a charge would be reduced. So jumping on to my code for this one. I take first all the moments as input. Then I maintain a previous moment when the phone must be on. Initially we are given that we turn on phone at 0. And I maintain a current pointer where when my current time when phone should be on. I take first find out the time t, which is difference of both of them. And either I can waste, keep running the phone and the energy consumed would be d into a, or I can turn off and on. In that case, the energy consumed would be b only. So minimum of both of them, might subtract this from f, that would be the new charge when you have reached a particular message. If at any point the charge decreases by is less than equal to 0, I maintain a boolean flag where fl is true and false. True denotes like it's possible to send all the message. False denotes it's not possible. So at last we can print yes or no based on whether FL is true or not. So that was the idea for it. Any questions on this one before I move on to the next problem? So moving on to problem D now. My solution might get hacked as well. Like just try to prove something. Probably let me first check the idea for D. Reading the problem D first. Petya has an array A of n integers. His brother Vaisya becomes envious and decided to make his own array of n integers. To do this, he found m integers b, where m is greater than equal to 0. Vasya wants to make his array as different as possible from Petria's array. Especially, he wants the total difference D of both the arrays to be as large as possible. Help Vasya find the maximum difference he can obtain. Like, my solution was also proved by AC, so I won't be surprised if this one gets right. Like, I can say that what did the intuition I had. Like, let's look at like the first one of the test cases first. So like, let's take the first sample. It says A is 6124, B is 351723. So the idea is we have to first select 4 numbers from this. Let's say we have selected let's say we have selected 1, 2, 3 and 5. In that case, our A would be 6124 and B would, like the new array which the other person contains, would be 5, 1, 2, 3, and then we can rearrange it in any order we want. So like if we have chosen this, like one possible way to arrange them is 6124 and 3, 2, 5, 1. And then we have to take the difference of absolute values of both of them. So now the difference of absolute values, like absolute value of difference, in this case 6 minus 3 is 3. In this case 1 minus 2 is minus 1. Absolute value is 1. 2 and 5. In this case the difference is minus 3. Absolute value is 3. In this case the 4 minus 1, the absolute difference is 3. Absolute value is 3. So in this case the possible value is 10, is the difference level. Like it's not necessary that it will be optimal. Like this is just the process of what we are doing over here to get a hang on what is the problem we are looking at. Like initially we are given 6124, then we have an array 351723. We have to choose any 4 numbers over here. Let's say we have chosen 5123. Now we can arrange them in any order we want. Let's say our order is 3251. Now we have to take the difference of all the corresponding number, their absolute value. Like if it's negative, make it positive and take some of those values. So like when I have arranged it in order 3251, the absolute value was 10. Like this is one way of doing it, but it's not necessary that this 10 is maximum. What we have been asked is we have to repeat all of the process. So that our final, that sum is maximum possible. So like the idea I had over here was like there, let's say our final chosen array is C. Let's not care about the order to begin with. Then there can be two cases. Either AI is greater than CI. In this case, the value of difference would be CI minus AI, or AI would be greater than CI. In this case, our absolute value would be AI minus CI. Because our A's are fixed, what we can do to increase value over here is take C as large as possible. And the idea here was we should take C as small as possible. So if we say that for I elements, AI minus CI holds, And for j elements, for I index is greater than ci, and for j number of index ai is less than ci, then here we should pick the largest. Here we should pick the smallest values, and here we should pick the largest values in B. So like that would be our idea over here. And after we have chosen these values, what we can do is we can increase the number. We can make A in the sorted order. And assign these largest values to smallest j values in A, and these smallest I values in B with largest I values in A. And what we can do is we know that the sum of I plus j is n. So now we can iterate over possible values of I and find the sum range of sums over here. And like this should solve the problem. So like, and to find the sum of smallest I values or the largest j values, I can use prefix sum array or anything else as well. Now jumping on to my code for this one. Like first I took A and B as input. Then I have sorted A and B, like adding minus infinity so that I can make the smallest number 0. You can also put 0 over here, that should be fine. Then prefix sum for A and B such that now AI denotes the sum of smallest I elements. Now I am maintaining answer like what can be the maximum difference possible. If I fix the number of smallest numbers I have to take, and here I am taking AI as the sum of smallest I numbers, and BM minus I would be sum of largest I numbers in B, and J is the number of elements where the other type of equality holds. So here I take the sum of largest J numbers in A, and here I am taking the sum of smallest J numbers in B, and at last take maximum of this and print it. One question you may ask, like what is the condition that, like it can be the case that there is no place where sum of I numbers holds, right? I started by assuming that all the possible values of I and j are possible over here. So here this part was mostly proved by AC. The main idea was if this doesn't hold, then whatever value we will get would be less than the value we had at the time. Like for example, if we have sorted A1, A2, AN in increasing order, we have decided that we want to take BI smallest values and the rest of the values are large. If let's say over here like AI minus BI, we were assuming that this case holds. But if it happens that in fact this is true, then we can notice that this difference would be less than when you have I as -1. So like in this case, like this would not be the definitely the maximum case we have. So it's safe to ignore those cases. And like that was the idea for this problem. So I will repeat the process again. First, I started by claiming, like, let's say we have chosen n numbers. And let's call those final numbers as C1 to Cn. It happens that either AI is less than Ci. In that case, our final answer would be Ci minus AI. Or AI is greater than or equal to Ci. In that case, our final value would be AI minus Ci. And if Ci minus AI is the pair, we should pick Ci as large as possible. Or if AI minus Ci is the case, then we should pick Ci as small as possible. Now this gives us an idea. Like if for I index AI is greater than or equal to Ci, then we should smallest I values in Bi. For j possible number of indexes, AI is less than Ci is possible, then we should pick the largest j values from B. And we also have a condition that I plus j is equal to n. Once we have decided that, like, we should pick some set of small values and some set of large values, what we can do is, for the assignment, like how should we arrange them over here, what we can do is, like, for all, we can pair all the large values with all the smallest values of A, and for all the small values of A with all the large values of B. Like that was the main idea. After that, I made a for loop from 0 to n, like the number of times I equal to j holds. And my claim was, for the optimal answer, we would always have those I and j possible cases. If it happens that exact I and exact j is not possible, whatever my algorithm is finding would always be less than the other case. And then I jumped onto the code for this one. So, like, any questions on this one? So in that case, I will move on to problem E. Okay, problem E says, eat the chip. Alice and Bobs are playing a game on chalkboard. The board has H rows numbered from top to bottom and W columns numbered from left to right. Both players have a chip each. Initially, Alice's chip is located in the coordinate XA, YA, row XA, row YA, and Bob's chip is located in YA, XB, YB. It is guaranteed that the initial position of chips do not coincide. Players take turn playing moves with Alice starting. On her turn, Alice can move her chip one cell down left, or one cell down right, diagonally. Bob, on the other hand, can move his chip one cell up right, or up left. It is not allowed to make moves that go beyond board boundaries. Formally, if at the beginning of the Alice turn C is in the cell with coordinate XA, YA, then she can move her chip to one of the cells XA plus 1 YA, or XA plus 1 YA minus 1, or XA plus 1 YA plus 1. Looks like there is, okay, yeah, XA plus 1 comma YA, XA plus 1 comma YA minus 1, XA plus 1 comma YA plus 1. Bob, on his turn, from the cell XB can move to cell XB minus 1 YB, XB minus 1 YB minus 1, or XB minus 1 YM. Then the new chip coordinates X dash and Y dash should also satisfy, like they are in the given range on the board, like you do not move out of the board. And if you look at the diagram over here, if this is the place where Alice's chip is at, then he can either move to this cell, or this cell. Or if this is the place where Bob's cell is, then then he can move to this cell, or this cell. Like three possible choices. A player immediately wins if they have placed their chip in a cell occupied by the other player's chip. If either player cannot make a move, that is Alice if she is in the last row, that is X equal to H, or Bob if he is in the first row, X equal to 1, the game immediately ends in a draw. And we have been asked what will be the outcome of game if both of them play optimally. So moving on to the solution for this one. Like one here in the first sample, we are given that like we have 6 x 5 grid, and the Alice is at 2, 2 and Bob is at 5, 3. And it's pretty much the same sample we are given over here. And what you can notice is like there are two possible moves over here. In Alice's turn, he will move to x equal to 3. In Bob's turn, he will move equal to x equal to 4. And in the next turn, Alice would be equal to 3 at x equal to 3. So like Alice will move 2 times and Bob will move only once. And using the case over here, what we can see is like we can first count the number of moves when they will meet. When they can meet, not they will, they can meet. And this would be like the number of total moves. Like in Alice's case, the x coordinate increases by 1, and in Bob's case, x coordinate decreases by -1. So the moment when both of them will have equal coordinate would be when, let's say, the difference of their coordinate is t. And on t plus 1 turn, their x coordinates would be equal. In the turn just after that, their coordinate would be different, and now Bob will be at lower coordinate and Alice would be at lower coordinate. To summarize again, let's say this is our initial structure is. Alice is somewhere over here, Bob is somewhere over here. In the first turn, Alice moves 1 coordinate. In the next turn, Bob moves 1 coordinate. Then in Alice's turn, he moves 1 coordinate. Then in Bob's turn, he will move 1 coordinate. And after this has been done, like Alice moved down and Bob will move up. It's no way possible that both of them can have same x coordinate. So by just looking, and here if you look at it, 1, 2, 3, 4. Like 4 was the difference between the coordinates. And in each turn, the difference of the coordinate decreases by -1. By 1. So by just looking at the difference of x coordinate, you can say that either Alice will win or it would be a draw, or either Bob will win or it would be a draw. Because whoever gets to the same x coordinate later can either be at same y coordinate or cannot be at same y coordinate in case it would be a draw. So first we should find like who can be the potential winner. And now both of them knows. Like let's say by looking at the difference in x coordinate, we found that the Bob would be the one who would win. And now this is how the board looks like. Let's say Alice is somewhere here, Bob is somewhere here. Now because Alice knows that he can never win, let's say because based on the number of moves, Bob's would be the second person at 0 coordinate. So if this is how the configuration looks like, it's optimal for Alice to first move as right as possible and then at last move like this. So to chase Alice, Bob will have to come to the final coordinate only. This is the case when the x is on the left side of Bob. Similarly, if our original graph looks like this, like original place, where Alice is on right side of Bob, and we know that Bob must win, then Alice should move as right as possible and at last move down. In this case, Bob will have to travel the complete journey to the right over here. if both of them have same coordinates, then you can just repeat it. If Alice moves right, Bob moves right. If Alice moves left, Bob moves left. If Alice moves left, Bob moves left. So in this case, we can for sure that Bob will be able to catch Alice. Now we have to also see, since we know that the final right times Bob will have to move, like that should be the number of turns Bob should have. Like let's say Bob reaches the same x coordinate in 3 moves, but to reach the right mode position, Bob needs 4 turns. Then in that case, Bob will never be able to catch Alice. Similarly, for the other part as well, if Bob has to travel this side 5 units, but when they have same x coordinates, like Bob have played only 4 turns till then Bob will never be able to catch Alice. And like that was the main idea. Yep. Summarized by looking at the difference, we can find who can be the potential winner. And like that, we know that other person will never be able to win. So the optimal choice for the other player is to move to the one of the possible coordinates of the board and just go down over there, so that the other person has to travel the complete other side as well. And now we can compare like whether Bob will reach at the same x coordinate faster or the left side or right side faster. And by checking at them, we can see whether Bob will win or it will be a draw. Now I will jump onto my code for this problem. How did I decided the optimal winner? Yeah, probable winner. Okay. Okay, I will repeat that part once again. This is this, and x coordinate of Alice is xa, and y coordinate of Bob is xb. And look at their difference, which is xa minus y. When it's Alice's turn, he increases x coordinate by 1. So their difference, if it was di before, let's call it xai minus xbi. Basically, xai and xbi is the x coordinate when we have played I different moves. So if it's Alice's turn, then we know that xai plus 1 is xai plus 1. Because Alice moves down. And when it's Bob's turn, Bob's moves up, so xbi decreases by 1. If Alice turn. And because Bob does not changes his turn, it remains same. When it's Bob's turn, Alice does not do anything. Alice coordinate is same, but Bob's coordinate decreases by 1. In this case, if we look at the new difference of both the coordinates, which would be 1 plus di. And in this case, if we look at the new difference, this is minus 1. Which is again 1 plus di. So in each problem, in each turn, the value of xai minus xb increases by 1. And only when this value is 0, both of them can be probably at the same place. If this value is negative, they cannot be at same place because their x coordinate would be different. If their value is positive, they cannot be at same place. So using this difference, now we can find like the number of times when the turn number when their difference x coordinate would be same. And like that was the idea. Any question again? So like that was the idea. Now once we know the probable winner, like the next idea would be like the one who can never win tries to go to as far in the x coordinate or y coordinate possible, based on whether he is left of the other person or the right of the other person. And like that is the idea. Now I will move on to my code for this one. Like I try to simplify things by reusing the code instead of adding a lot of if else. If initially xa is greater than xb, then xa would always increase and xb would always decrease. So they can never meet. It's a draw. Print it and continue. I then we should take the look at the difference of it. Like I have taken a plus sign, but you can also take minus sign. The only thing we need is whether the difference is odd or even. If the difference of two numbers is odd, then sum of those two numbers would be odd as well. If the difference of two numbers is even, their sum would be even as well. Can't we use BFS to solve this? Let me look at the console. No, we will not be able to use. Yeah, we can use BFS. Like we have been given that the sum of H is up to 1 is 6 only. So instead of trying to find in order one, we can always just simulate this idea. Like that should also work. If it's Alice's turn, increase X A by 1. And if we know that Alice can never win, try to move it to the other side. If it's Bob's turn, look at where he's going and move it other side. This will work because we are given that the sum of H is up to 1 is 6 for all the test cases. So if you directly simulate after observing so far, you would be able to get an AC on it. Because I did not notice this constraint, I assume that H is also up to 1 in 9 or something like that. So I tried to find an order 1 solution for it. And order 1 solution was like I can directly calculate how many moves a particular person needs. So here I looked at if the sum is odd, then we know that the winner would be Bob. And I can swap XA and XB. My idea was I will try keep XA coordinate such that XA is trying to chase XB is trying to chase XA. And a variable win which is Alice or Bob who would be the potential winner. Otherwise I can simulate one move and keep it. So after the end of this move, my win string would be equal to who can be the probable winner, and also that the probable winner would have a second turn. Also the probable winner would have the second turn. So the first person plays some move and probable winner tries to chase them. Now we can look at the number of turns like the probable winner would have. That would be equal to their difference in their coordinate by 2. Because if now the remaining number of turns is 5, then probable winner would get second turn, because after this move I have ensured that the probable winner plays second. And I have also maintained a variable move, which is like the number of times one should move right or one should move to the left. So if XA is greater than equal, and here I have also added the difference of YA and YB. If the difference is 0, directly print the probable winner. He will just mirror it out. Otherwise, if XA YA is greater than YB, then other person will have moved to the complete left hand side, which would be YB minus 1. Or if YA minus YB, then the other person will have to move to the complete right hand side, which would be W minus YB. Now, like the number of turns you have and the number of moves, like the additional move and the difference, and you compare it over here. Based on you decide whether it would be probable winner who would win or it would be a draw. Like that was the main idea. instead of this condition, you can probably also use ya over here and ya over here, and you will not need a sum over here in that case. And like that was the idea for it. Like I tried to find in order one, but you can also use the same idea I had and run it after each move. And because the constraint is sum of h is less than 1 is 6, it will get an AC instead of a TLE. So like any questions on this one before I move on to the next problem? So I will move on to problem F now. Okay, problem F is sum of progression. You are given an array of n numbers and there are q queries of form S, D and K. For each query, find the sum of elements as into 1, as plus d into 2, up till as plus d k minus 1 into k. So the idea is you assume S and D as a arithmetic progression. You find all the indexes corresponding to arithmetic progression and you multiply first number by 1, second number by 2, third number by 3 and last number by k and print that sum. I will take one sample example. Like if you look at the first example, it says that A array is 1, 1, 2. The first query is S equal to 1, D equal to 1, K equal to 2. If you find if you write this as arithmetic progression with K numbers, the first number would be 1, which would be 1 like S only. The second number would be S plus D, which would be 2. And because K is up to 2, you don't need other problem over here. Now you have to find the elements at first and second index. Here it's 1. Here it's 1. You multiply first number by 1, second number by 2. Your sum would be 3. And I think that was the answer for this. 1 second. Yes, the answer for this would be 3. If I take the next query, my array is 1, 1, 2. Like I confuse the given array with the first query. First query is S equal to 1, D equal to 2, and K equal to 2. The first number would be 1. Second number would be 1 plus 2, 3. The third number would have been, if possible, was 5. The next number, if possible, was 7. The next number after this would be 9. But because we have to take only the first two numbers, we only take 1 and 3. After we look at the values at 1 and 3, it would be 1, it would be 2. We multiply first number by 1, second number by 2, and take their sum 5. So the answer in this case is 5. Like that was the main idea for this. One tip which I always say is try to absolve the problems which you are not able to solve it. The reason for this is now the intended solution which I will share. Like the same solution was used in the recent beginner contest. Yes, I had used the same solution for this problem as well. Here also, like I will give this as an homework. And here also, if you notice, there would be a similarity. There is a given x coordinate, there is a fixed difference, and like there is a variable part. So like let's look at two possible ways to solve this problem. First is we can do the brute force approach. We run a for loop j equal to 1, j less than equal to k, j plus answer plus equal to a of s plus j minus 1 into d. Like this would be what we have been directly at every point we are running the query and finding the value of it. And if we try to analyze the time complexity of this, like k can be up to n, and if s is 1 and d is 1, you will transverse the complete array, and your overall time taken would be order n. And because you have q queries, your overall time to solve this problem would be order nq, and it will get TLE. Now let's look at one more method to solve this problem. The other method I have is, let's first read all the queries. And let's try to solve all the queries for a fixed d together. And fixed f for d. So the idea is, once you group all such queries together, then you can, let's say your s mod d is r. Then let's write down all the indexes at once. ar, ar plus d, ar plus 2d, ar plus 3, up until some final index ar plus ld. And now if you find s, like s would be somewhere over here, because s mod d is r, s would be equal to some kd, k, let's not use k, s would be equal to some ud plus r, and our final number in the sequence s plus k minus 1 d would be equal to u plus k minus 1 d plus r. And this would be some part of this given sequence. Like the final array would be some part of this array. What we can do over here is, we can, now we know that we have to start from some index in this array. Let's call it C array. We have a C array where, let's call it C0, C1, C2, Cm. We have to take some array, some part of it, and then multiply corresponding index by 1, 2 up till. So the way we can do is, we can find two values for each number. One is prefix sum, which is sum of all the numbers from C0 up till Ci, pref sum I. And let's call some S sum. Yeah, P sum, like S sum call. Let's call it S sum, where S sum I would be sum of all the number I multiplied by their index. So to summarize again, my P sum would be of I will just scroll it over. Not again. Now it looks like it's messing it up. Like, let's say we have fixed a particular value of mod and number. We are number C0, C1, C2 up till Cm. Now I am defining now I am defining C1, like 2 1 pref sum is C1 plus C2 plus C3 prefix sum of this array. Let me just like, can you say like the time it took for the constant equal to 450? Like, my idea was, if I try to solve a particular value for fixed sum of S modulo D and a fixed D pair R and D, and my numbers would be of, and if I list down the numbers AR plus D up till whatever we have AR plus KL, and my claim was S are given sum would be in some range from it. So if we list down these numbers and we call them C0, C1, C2, C3 up till Cm, like this is one array, and I create one more array which is 0 into C0, 1 into C1, 2 into C2, 3 into C3, and M into Cm. And I take prefix sum of both of them, P sum, and let's call it S sum. Then let's first, like, let's say our S is in this range from 3 to, let's say, 8. Then if we take a difference between L minus 1 and C, what we will see is like we can write it as 3 C3 plus 4 C4 plus 5 C5 plus 6 C6 plus 7 C7 plus 8 C8. And we can add plus 2 C2 plus 1 into C1 plus 0 into C0. And we can subtract the same part. If we I will repeat again. If my sum starts from, let's say, 3 to 8, then if I write this value 3 into C3, 4 into C4, 5 into C5, 6 into C6, everything, and I can add the other parts to it. I can first add and subtract this part. And I know that I can found both of these sum using my S sum which I initially created, which was prefix sum of I into Ci. And if I notice what I really need, what I need is 1 into C3 plus 2 into C4 up till plus 6 into C8. And if I look at difference of these two values, like every number is extra 2 times. So I can directly separate 2 into C3 plus C4 plus up to C8, which I can find by using my prefix sum of the given C array. So this is one other way to solve this problem. And if I try to find time complexity, what we can do is, like, we can add test cases of form q plus plus string sd and let some random k. If q is greater than 2 into 10 to the power 5, break. If there is a test case like this, okay, s modulo d was some reminder value, like there would be some value for that s modulo d. It's just representing like at what all indexes you should pick if you take modulo d. Like it's not necessary, like it's like basically I am adding negative indexes to my given sum as well. Like s is the first index, what I am trying to find is s minus d and negative minus 1 index, artificial index I am creating. S my like k minus 2 like would be s into minus 2 times of d. The idea was if you look at all of these indexes together, they would be at some fixed index which would be same for all the values. And like I was trying to group all these values together, like looking at like what would be the arithmetic progression array over here. And the idea was if you look at all the values which are at d distance from each other and first values at s modulo d, then your arithmetic sequence would be some continuous segment for that array. And in a test case like this, s modulo d and d value would be distinct for all the queries. And for each query, you are creating around n by size array. And your overall time complexity to solve a particular d would be d, like to solve a particular s modulo d, particular value of s and d would be around n by d. This would be the size of array you will create. And like this would be the number of elements you will create, like you will process d queries. And it will take around order 1 time. Or let's pick up the worst case over here. Like for each query, you are creating an array from scratch and you only take s equal to 1, equal to 1 and k equal to n. In this case, you are creating the complete array from scratch, finding all the prefix sum and trying to find it. So your overall time complexity would be order for each query and total time for test case would be order n into q. And this will also get TLE. Now the key idea to solve this problem is if d is less than equal to a constant, say 300, which is around square root of n, then use the second algorithm. And if d is greater than a constant, say 300, use the first algorithm. You will get an AC on this problem. And this technique is known as square root technique. You have two different ideas. Individually, both of them will get TLE. But if you add some if logic to process one algorithm later and the other algorithm based on that if logic, you overall time complexity reduces by some constant factor, not just a plain brute force. I will leave proving the time complexity as an homework exercise, or you can watch CF stress editorial for the encoder problem I have said. Like you can watch CF step editorial of above problem to try to analyze like how to solve this problem. Now I will show my code for this problem. The idea is I am taking all n and q as input. I'm maintaining a whereas, like that would be my result, and at last I will print that result. I iterate over all the queries. Take S, D, and K as input. I have defined a constant R which is around 360. If D is greater than R, directly brute force using the order and algorithm I have said. The key idea here is, since you are doing in the jumps of D, the number of times you will jump would be at max n divided by D. And because R is greater than 360, and n is around 1e5, n by 1e5 divided by 360 is around 360 only. And number of queries are 2 into 10 to the power 5. So 2 into 10 to the power 5 into 360 would be around less than 1e8 or something like that. It should not be difficult. Otherwise, I am mixing all the queries. Here I have done it in the form of directly D only. Instead of S modulo D, you can maintain a map over here, map of pair, where you push it into S mod D comma D and put the starting value of and the ending value of D and the index value should be. Now I am iterating from D1 to N and D less than equal to R because I already solved the queries for D greater than R. If the current vector is empty, ignore it. Otherwise, I am maintaining a pair of vector, which is P sum and C sum, which I have explained in the editorial. Like here, I am trying to solve all the values together. You can take it in one shot as well. Map pair. Like, let me just open my code editor once. I'll show you that part. Map of pair of all the queries. Now we can also try to find at which place my current element would be. Like the left part which I should subtract and the first part which I should add. Now V is definitely not empty. I can start with R. Doing jumps of D and also maintaining J equal to 0. Prefix sum. Let me call, I will call it as sum. Push back. Now I iterate on all the queries. I have left pointer, right pointer, and where I should have the final answer. I'm taking like the final answer should be R is S minus 5. And then if L is greater than 0, like the second sum was S sum, like the weighted mean I had. And here you multiply by the left coordinate. if L is greater than 0. Like that would be the code, like brute code. Like I can be off by 1 somewhere over here. So like I am not trying to compile it or code it, but that's the main crux for this problem. I will move on to the last problem of the contest. The idea isn't difficult, but implementation is what takes most of the time. My code as well, like I was able to solve E at around 8:52, and it took me around an hour or so to get the final version. So I will share my idea for this problem. Like most of the thing would be implementation, so I will give a walkthrough of my code. So and like I will say like how did I simplify. To read the problem statement G, it says mischievous shooter. One of the mischievous and Wynard shooter named Cell found himself on a rectangle grid of size n into m, divided into units where each cell either contains a target or not. Cell only had lucky gunshot with him, with which he can shoot in one of the 4 directions: right down, left up, right up. When fired, the shotgun hits all the target in the chosen direction, such that the Manhattan distance of which does not exist a fixed constant k. The Manhattan distance between 2 point xi and yi is equal to difference, absolute value of difference in their coordinate, and absolute value in difference of their coordinate. And like here you are given the possible shots for k equal to 3. If this is the point, this is the area where you can hit all the target if you choose this direction. So like one thing we can do at first is, let's say this is the grid, and if you are trying to shoot it, we said like we will only shoot it in this direction. This would be the only direction we will shoot in. But try all the possible 4 cases. What we will do is we will rotate the given image 90° each time. Try to find what would be the maximum answer if we shoot in this direction. So like this would be the first time. When you rotate it by 90°, if your grid looks like this, and when you try to find the maximum value over here, it's equivalent to finding the maximum value than where you have rotated the gun by 90°. And when you rotate it 90° again and 90° again, it will cover all the possible directions. So instead of writing the code for 4 directions, let's write a code to rotate the given image 90° 4 times and try to find the maximum answer when you sort only in this direction. So like that was the first part I did. Now once we have fixed a particular direction, let's see how does the value where we shoot changes. Like at first this is the area we will shoot, and if we move to the right by 1 point, our new area would be, sorry, looks like I missed the part. Like let's say this is the direction, and like this would be the area you will shoot on the first shoot when you are at 0 coordinate. And if you move right a bit, this would be the area. And if you notice their difference, like what you have done is you have deleted this and you have added these blocks. So if you can find in constant time, given a diagonal and arrange the sum of points in the diagonal, and given a column and arrange sum of all the points in that column. Then you can find, if you know the number of bombs you shoot at this position, you will be able to find number of bombs you shoot at this position if you are moving right. Similarly, let's also analyze the case when we are moving left. This should be the initial blocks. And if you move one position up, the new range of blocks would be this. If you here you are removing some of the boxes in a particular row and you are adding the points in a particular column. So if you can solve queries of a form, like find the area of some range in a particular row, find the sum of all the points in a particular row, and find the sum of all the points in a diagonal, you will be able to, if you know the answer for this point, you will be able to find the new answer for this point. Yeah, like for 458 858 milliseconds for a time limit of 2 should be fine. Itachi, I was telling you. So like now I will move on to the implementation for this problem. Like one thing you can notice is that for a diagonal, the sum of x and y coordinate is equal. Like only like x coordinate changes over here. So like this was the main idea, and now it's implementation, which will take a lot of time. I will give a walkthrough for this code. Like let's first look at MLE part. I first took the given matrix as input, where B is the character where there would be a bomb. Then I have a rotate function, which does a rotation by 90 degree. So like length becomes breadth, breadth becomes length, and I comma j coordinate moves to the this coordinate. And now I also have a solve function, which finds optimal answer for this given A. And the idea is find optimal answer, rotate by 90 degree, find optimal, rotate 90, find optimal, rotate 90, find optimal, print answer. So this removes all the extra logic you have. And now when I'm looking at the coordinates, my points ij is 1 if that coordinate has a bomb and 0 otherwise. Whereas ij is a vector which will denote like the number of items you will shoot if you are at coordinate I comma j. And then I am running a for loop to find the value for v0 comma 0. Now calls is my array where the left hand side is the index of column and the other side has length n. It denotes prefix sum of a column. So like you take first as the current value and you add previous value if your I is greater than equal to 0. Rows is my similar prefix sum for the rows, where ith index denotes jth index in the ith row denotes sum of first j values in a row. Points, and if j is greater than 0, find all the sum. And now I also have a fixed sum, like it's for a diagonal, because you can identify each diagonal by the sum of their x and y coordinate. Here I am taking sum of ij and index I denote for this column what would be the sum if the numbers are up to I. And if anything is out of the matrix, we just denote is at 0. And if you move on to the next column, you add this like prefix sum for the rows. Now I am running on the complete matrix. If my j is equal to 0, I is equal to 0, I have already found the answer. Otherwise, if j is 0, I is 1, then it moves to like shifting the matrix up. This case. So I find the fixed row for this diagonal, add it to the current value, and I subtract the sum for the row. Like I am subtracting this one and continue. Otherwise, I am making movements of form. I am making movements of form this. I am taking a column sum. Like I am taking the value just above it, subtracting the column sum, and find the diagonal sum over here. And after the end of this loop, my value will have corresponding values for all the indexes. Iterate over everything, take the answer with max. Like that is the idea. Now here it was MLE, because if you look at fixed sum, like its length is m into m and n is n. So if n is 1e5, this takes around 2e5. That was the MLE. So it tries to do it smartly by removing all the zeros, by maintaining minimum index in a diagonal, maximum index in a diagonal, and then prefix sum using some vectors, like optimization on this part. And then if you are out of something over here, like earlier I was marking everything as 0, here it's just removing everything from the memory over here. And that was the idea for this one. Like this problem is more implementation side rather than some logic side. So you should try to code it later. Like it's fine if you look at someone else algorithm or someone else code, do understand why that particular code was working and try to implement it. And this pretty much completes my stream for today. And sorry for all the issues in the beginning. Like I am not sure like why my fans started running too fast when I was trying to stream it. Like one reason was I tried to make my stream in HD, and like that in turn ended up using a lot of CPU over here. And like when I tested it in my private stream, everything was working fine. Just that, like it was more like in staging, everything is working fine. When you go to production, you find a lot of new issues. Thank you for bearing me until 1 in the night. And like someone did ask some of the question, I can take some of the questions in the chat. Like Music World is asking, oh, how can I properly start CP? I have a rating of around 624. My advice, if you are just starting it, would be start with AdCoder beginner contest. Like initial problem in AdCoder beginner contest are mostly implementation. You read the problem, you code it, and try to solve them. And then if you want to like for beginners, my first advice is try to participate in a lot of contests. A lot of people think that they will watch a lot of videos related to DS and everything, and they will try to code everything at last. Like this strategy doesn't work. If you want to be good at computer programming, you will have to code. If you are beginner, just code a lot to begin with. Once you get a hang on it, then you try to learn different algorithms by watching different blogs, videos, and everything. So start with AdCoder beginner contest. Participate in contests like if you are Div 3, Div 4, Div 2. And like one problem which happens with beginners is like they just solve one or two problem, their rating drops, and then they get demotivated. So like probably for the initial 6 months or 9 months something, just don't look at your rating, just go there, participate. Okay, I have a rating of 1400 and not able to improve. Like probably it would be better if you can share your Codeforces handle. No, Music World, if you are just starting, don't look at the DSA concept or don't try to go for like I will attend a lot of videos or I will read a lot of blogs and solve it. Like the first thing is you try to code a lot of problems, which are Codeforces A and B, or AdCoder beginner contest A, B, C, or D until then. And those problems will not require much concepts. And if you are not able to solve it, you can always read at the editorial of the contest. You can see like how others are solving and read over there. Yes, no mercy. Like I hope you beat me someday. Why? Like I remember you had a challenge with me. So like if you are 1400, the other strategy with I recommend is like if you are let's say participant for 6 or 9, you are consistently able to solve Codeforces due to A, B. Then the other idea is like to do virtual contest like I suggested some people in Discord to start solving ad coder virtual contest from the contest number 1. Yeah, like I am currently using Java for CP. Like also for problems like A and B, like programming language doesn't really matter. Like people try to install that main language, at least Python, C++, and Java does not struggle with TLE. So like in the end, if you want to continue CP, you will have to switch to C++, but it's not required when you are just starting it. You can start with Java only. Can you discuss your log and interval idea for the above questions? Which was the question, Rajiv? Probably if you can say. Like I don't think I had a log and idea. Like arithmetic progression was the square root idea. Like that's known as square root technique. You made a complete video and lecture. Like no, I don't think my solution was. My solution complexity was more on the q into square root of and something like that. Like you should check out this blog where Ericto has mentioned a lot of problem like square root technique complexity, and like he also has a video editorial on it and some homework problems. So if you try to solve this, like you would be able to solve problems like F in today's contest or add code a beginner contest in the previous to previous contest. And I think I am taken all the Q&A. So like thanks everyone for joining and bearing with me today. Any book recommendations? Like if you really need a book, there is CP handbook. There is a problem set for this book as well. So this is other place where you can start to try solve. There are introductory problems. Then there are some problems in sorting, setting. Yeah, I agree. C blocks are better than any book. Like the most of the techniques I learned was using Codeforces block, dynamic programming. And if you look out for YouTubers, like there are people who have created a video editorial for all of these problems. Someone has created for all of the graph problems and everything. So yeah, pretty much that's it. So yeah, thanks everyone for joining. Okay, bye. And with this, I will end my stream. Good night.